Hi guys, this is Mrs. H, and I want to take you through the journey of taking a measurement in this video. So there are three parts to taking a measurement. You need to record the magnitude of the value. How large is the value? In order to do that correctly, you must first make sure you're reading the scale of the instrument correctly, and then that you're reading the position on your instrument as well correctly. The second is to make sure you're finding on your instrument and recording the value unit. And then the last one is something called precision. That essentially means the number of digits. That's going to depend only on the instrument. Our rule of thumb is that the last digit is always a guess and don't drop zeros. So, for instance, I have three caterpillars here, and my first caterpillar, my position on my scale, I've got it, I'm reading between 0 and 3. And when I say that my last digit is a guess, I'm really guessing that that caterpillar is around 2 centimeters. Um, and so that's the only value that I can record there. When I add more lines onto my ruler there, I now know that my value is between 2 and 3, so I can add another digit of precision. We're estimating that it's 2.3. It could be 2.2 or 2.4 or even beyond. The third one there, now I've added another entire set of markings, each with an increment of zero point 0.1. And so now I know that it's between 2.3 and 2.4, and I can add another digit that is my guess. The purple line down there is a reminder. If I were to measure that purple line, and let's say I thought that it was exactly at the value of 2, because I'm measuring it on that third ruler, that means that my instrument tells me I need two significant values, and I would need to record 2.00 centimeters. So don't forget to add necessary zeros. Don't leave them off if you believe that the value is a 0. Okay, so I have a number of practice ones here so we can really take a look and jump through these. And so when we're deciding where to take the measurement value, um, the curvature of a liquid becomes a little bit of a problem. And so that curvature is called a meniscus, and that's due to some surface tension. You'll notice that in the bottom over there, some liquids curve down and some liquids curve upward. And so most of the time we'll be measuring water, which is curving upward. But if you did have a very dense liquid, it might curve downward. Okay, so for the first one up here, you're noticing where the viewer is taking the measurement. First of all, the viewer must be at eye level, and then you're recording the value just where the bottom of that meniscus touches. So the bottom of the curvature. If it was curved the opposite, you would be measuring the top. Okay. And so for this one, I know that my value is between 36 and 37. And so I can record a value of 36 point, and then this is my guess digit. And so I can say 36.4, and you might have written 0.5. And then I'm assuming this is milliliters, even though the container is not marked. So for this beaker, I can see that my value is between 40. There is a marking at 50, so that is a marking, even if there's not a number there. So my guess digit is this one. I know that it's between 40 and 50, but I'm not very sure on that 5 digit. So you may have recorded a 44 or a 43, or even slightly different. Okay, on the next one, I have 35, 36, 37, 38, 39, and 40. So my markings are one apart, which means that this one I can record definitely at the 36 mark. And then a decimal place indicates that someplace between 36 and 37, I'm going to put the bottom of this curve at 36.4 milliliters. So again, I'm reading the bottom of that curve. All right, the next one I included because often students get sidetracked and they don't realize that this one is counting in the opposite direction. And so this one is starting at 0 at the top. And so I have a 0.1, 0.2, 0.3. And so this one would be recorded at 0.3. And then my increment in between here might be a 5. Okay, let's put one over here that has markings at 0, 2, 4, 6, 8, and 10. And I want to measure that blue line right there. And with this sort of instrument, my value does not add because I don't have a marking at every single value. What I'm going to record here is 7 centimeters. That's only one digit. That digit is a guess. The difference is that a guess, when I have markings of every 2, is a better guess, but it is still a guess at 7. Even if I had just a 0 and a 10, I would still have been able to guess 7. And the difference will be on the next page when we look at error. Okay, so this one, the curvature is sitting right below that line. So remember, the curve is going to rest, the curvature is going to rest on your measurement value. So I'm looking at my values, 40 to 50, that puts it 45. So I'm making sure and confirming my scale here, 41, 42, 43. I actually don't think it's on the 43, so I'm going to go with 42.9. I wanted to see some real world type examples here as well. And so in this one, I have a liquid that is, you can see the meniscus is not perfectly looking like the little lines in the pictures above. What I'm looking for is my meniscus is going to rest on top of the value that I'm measuring. And so in this case, I have 70 1, 2, 3, 4. And I do have a marking at each spot, so I have 74 milliliters. Okay, the next one is another real world example. My meniscus would be resting just where it's touching. It kind of curves just below that marking there. So this one is an irregularly marked scale. So you'll notice the 20, counting up the 21, 22, 23, this doesn't 1, 2, 3, 4, 5. Every other marking is a value. And so this is 21 and this is 21.5, that little half mark there. And so this I would mark at maybe 21.4 as being just below that marking. And then we have a little commentary about digital measurements down here. What do you do with a digital measurement? Where do you take a guess digit? Um, Digital measurements are calibrated so that that last digit is actually your guess digit, which also means that if you have a very sensitive digital instrument, for instance, our balances, if you're putting something on that balance and the last number is fluctuating up and down, you don't have to actually wait for it to settle on a number because it has already been established that that digit is a guess. Okay, guys, hopefully that helped you with determining or recording values. We're going to add one more thing to that, and that's recording the instrument error. And so when you're recording instrument error, if this would be required, I would let you know. You would be recording by looking at the increment between the markings. And so, for instance, this one is labeled 40 and 60, but there is a mark at 50. So my increment is 10. And so half of my increment is plus or minus 5 milliliters for this particular instrument. So when I record that value of maybe 45, I would say 45 plus or minus 5. Whereas this one, my marking is at a distance of 1. And so I would record this one as plus or minus 0.5 milliliters. And so I would record this one as 36.5 plus or minus 0.5. All right, we are done for today. Thanks.